jacked up Jeeps. Like she'd be the best
She literally
safari
does.
driver.
Okay, we're on video now, so I shouldn't be talking about people.
Oh, it's all
Even though,
positive.
I know it's all
That's a
positive, but
compliment.
still, we'll talk about that now. So here we go. Everybody's got your review sheet. We have finished, the notes, at least the ones we're gonna do, we're finished. So now we're gonna get out our chapter 9 review sheet for the chapter 9, not the exam review, that's a different thing. We're looking at our review sheet for the exam, and it is big. Review sheet for the test. This is chapter 9, this is our test.
You do well in the optional.
So, has anybody looked at it yet? I have one extra copy up here, and then I don't know what, if there's any extras, I have one up here, and that's all. All right, so, cross off number 1, because that's what we skipped. So we're not doing number 1, or number 20. And I think that's it, those are the only 2. But if you find another one, just skip it. We didn't do mathematical induction. All right, so let's look at page 1. Does anything on page 1 look like something that we need to do? Anything on page 1?
Yeah. Like
Which one? Number 3. Find the 4th term of this expansion. All right, now, all the terms of the expansion have 3 parts. They have a coefficient, this one has a 4a and a negative 3b. So your job is to figure out the appropriate coefficient and the appropriate exponents. That's it. Okay? So, what do we need to know? We need to know that we are expanding to the 7th power, which would mean that the exponent, or excuse me, the coefficients will come from either the 7th row of Pascal's triangle or from the combination numbers for 7. So 7C7, 7C6, 7C5, and 7C4. Which term did I want? The 4th term, 1, 2, 3, 4, right there. Now, please don't think that that 4 has to do with the 4th term, because the 3rd term would have a 5, right? You got it? We get the 4th term by counting down. So, you can also get the 4th term by writing out Pascal's triangle to the 7th row and counting over to the 4th number. All right, so my coefficient is 7C4, which I probably should know that, it's kind of common, but I can't remember it, so it's 35. So my coefficient is 35. Now, I get my exponents by also counting, because I know that if I were to multiply this whole thing out, the first term would be a to the 7th. Foil, 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 a to the 7th. Here, it would be a to the 6th, 5th, 4th. I'm doing exactly the same counting I just did. So, that's a 4. And this one then has to be a 3, because they gotta add up to 7. Now, I have to simplify, keeping in mind that the exponent goes with the numbers also. So this is 35 times 256, a to the 4th, times negative 27. So we multiply all this together, 35, 256, and 27. I got negative 241,920, a to the 4th e cubed. Leah? Raise your hand up.
So for the exponent for, like, in this case, our a, or normally it's our x, does that always match the combination?
Yep.
So we can check ourselves?
Yep.
They always should be
I
the
always
same.
count, because I don't want to try to
Well,
remember
yeah,
random
yeah.
things.
But like, yeah.
Okay, I can't remember who asked for that, but it's done now, okay? So what else do we need to do? On page 1, we're starting on page 1. Dom?
You do 7A.
7A, find an explicit formula. We have a geometric sequence, so we know what that means. We don't know the first, second, and third, but we know the fourth term is negative 192. And that's fourth, fifth, sixth, seventh, eighth, and the ninth term is 196,608. So this is the fourth term, this is the ninth term, 5, 6, 7, 8, yeah. Okay? Now, what does it mean to be geometric? It means that to get from here to here to here to here to here, we multiply. So basically, to get from negative 192 to this number, I have to multiply 1, 2, 3, 4, 5 times. So I have to take negative 192 times my ratio 5 times to end up at 196,608. Now, does that make sense to you? We haven't answered the question, but that's what's happening, right?
That's how you write a geometric thing?
Huh?
No,
This, I'm trying to figure out what my ratio is,
Okay.
because I can't write a formula unless I know my ratio.
Yep.
So, first thing I'm gonna do is divide by, so 196,608 divided by 192. And then I'm going to take the fifth root of that, which is negative 4. So my R is negative 4. So I divided by 192 negative, and then took the fifth root of that to figure out that I'm multiplying by negative 4 5 times. Okay? Now, I need to know what my first term is. To write the formula, remember your explicit formula is this for a geometric sequence. I need to know the first term. I now know my ratio, but I need to know the first term. So if I got from here to here by timesing by negative 4, I will go backwards by dividing. So negative 192 divided by negative 4 makes this one 48. Then this one will be negative 12. And this one will be positive 3. Is that okay with everybody? So, 3 times negative 4 to the n minus first. That is your explicit formula. Remember, the formulas on your formula sheet are explicit. So you're just plugging in your first term and your ratio to get the one for this particular problem.
So how did you know that it was the difference for the ratio being negative 4? Like, was it always multiplication? I swear we did some revision.
Okay, but then it was arithmetic.
okay.
Then it was an arithmetic.
So that's the
sequence.
difference. Okay.
Yeah. Yes.
Like,
That's all right. Take a deep breath. It's okay. All right. Anything else on the front page of the review?
Makes you feel better about yourself, doesn't it?
8. If the track is wet. Okay, when you read through all that stuff, what are you thinking about in terms of a strategy? A tree. So, what is happening in the problem? Okay, we got a track, wet or dry, and then we have mud or earth, winning or not, right? So the question ultimately is, find the probability that mud or earth wins. That's ultimately the problem, or the thing. So she's gonna win or lose, win or lose. It's gonna be rain, or let's say wet, or dry. Oh, I can't do that. So rain or dry. So does that setup make sense to you? It's gonna rain or not rain, win or not win. Okay, so what do we got? If the track is wet, so in other words it rained, she has a 70% chance and a 30 of losing then, right? If the track is dry, she has a 40% and a 60%. Weather forecasts predict an 80% chance of rain. So do all of those numbers look right to you?
Yeah.
Okay. So we want the track to be wet, that's rain, and we want her to win. So since it's rain and wind, what are we gonna do with those two numbers? Multiply. So A is just 0.80 times 0.70, which I think is 0.56. Right, that's it, that's easy. Track is dry, and she wins. Okay, so this one was 0.56, this branch. Now, dry and winds would be 0.20 times 0.40. What's that? 0.08. So this branch is 56%. This branch is 8%. And the next question says, what's the total probability that she'll win? Well, she can win here, or she can win here. So that's gonna be 0.56 plus 0.08. And then it says, what's the probability that the track was wet given that she won? So, in my vocabulary, that will be rain given that she won. All right, and we have a little formula for that. It's called conditional probability. We take the probability of both, rain and wind, over the total probability of wind. Now, we actually already know both of those numbers, because rain and wind was this one right here, wasn't it? And total wind was this one right here. So reduce that fraction, looks like 7/8, or 0.875 if you put a decimal. Okay, Peter? All right, that one done. Anything else on the front page? Mary,
Could we just do one of the summation notations?
like where is that?
12 A or B.
Okay, you don't care which one? All right, let's do that. So we're gonna write this in summation notation, that we're doing 12A, which means that we need a sigma. I always start my sigmas with 1 because I find that easiest, but you could start with something else. Now I need to look at my sequence. What is going on in this sequence of numbers? We are adding 5, which makes it arithmetic. I need my explicit formula right here, and I just told Dom a minute ago, our explicit formulas are the ones on our paper. So for arithmetic, this is my explicit formula. I'm just gonna plug in what I know. So I know my first term is -8, and I know my common difference is 5.
Will we be given these formulas? Or will
Yes.
we- Oh, we
I
will?
thought I told you that, but maybe I neglected
You
you.
said the ones on the last page were there, for sure.
Well, you get the arithmetic and
And the
geometric
geometric.
sum and term formulas, yeah. So that's gonna be -8 plus 5n minus 5. So in the box, I'm gonna put 5n minus 13. You with me? Now there's one more piece. I need to know that top number. This thing stops. So, no, don't put 92 up here. What do we put up there?
What the term number?
The number that we plug in to get 92, right? So, cause like, look, if you plug in 1, don't you get -8? Yeah, that's the idea. So I need a number to plug in. So I need 5n minus 13 to be 92. So what does that have to be? 21. Check my arithmetic, is that right? That number has to be 21. And now the sigma's done. Now, the only difference with the other one, Maren, is it's geometric. So you won't use this formula, you'll use the geometric formula. But it's done exactly the same way. All right, anything else on page 1? All right, let's go to page 2, or at the back of page 1. Anything there that looks like it's something that we need to look at?
Can we just do like 1 of 13? 13F?
13F?
Yes.
Okay, now 13F, I need my summation formulas from my notes yesterday, because for 13F,
You have the 3.
we're gonna have to break it up. So let's see, we're going from 1 to 175, and my first one's gonna be 3k squared. And then I'm gonna have minus 5, so 1 to 175, a k. And then I'm gonna have plus that.
Will we also have the summation formulas on the test?
Yes, I don't have them memorized. You hardly ever use them. So I need to find my notes somewhere, find the right notes. Those are not it. Oh, here they are, right here. Okay, so I'm looking at my notes, and I am going to figure this one out right here. So this is gonna be 3 times. It's the k squared one, so that says 175 times 176 times 2 times 175 plus 1, 351 over 6. So that's the k squared formula. n plus 1, 2n plus 1 over 6. And I'm going to do that and then times by 3. The next one, I'm doing just my regular k formula, which is 175 times 176 over 2. And I'm going to take that times my negative 5, right, in a problem? Yep. And then what about this last one? This last one says we are just going to add up 175 times. So that's just going to be 75 times 1. Every
175.
Oh, 175, yeah, I wrote it wrong. Every term of this sequence has a plus 1 on it. So if we split it up, we have to add that plus 1 175 times. We just figure it out. Get this done. I don't know if this is right. I got 5,328,575.
Yeah.
So 5,328,575. Now, I use these for this problem because it was kind of like a polynomial expression there, trinomial expression. One like number A or letter A, that one's going to be geometric. So I'm going to use my geometric sum formula. And then one like D is going to be arithmetic, and I'm going to use my arithmetic formula. So for all those, you have formulas. You just have to kind of look at the terms and figure out which formula you're going to use. All right, anything else on this page that we need to look at? Yep, Leah?
Can you do 16?
16, I shall agents. How many parts are possible. Alright, so we're going from A to B. And we can get there directly, straight from A to B. Or we can go from A to C and then C to B. Do you understand if that's what the problem is saying? Alright, how many direct flights are there? We're just gonna get on the plane and go straight to B. There are 3. So I have 3 of these options. Now, how many ways can I get from A to C? 3. And then I need to get from C to B, and there are 4 of those. So altogether, if I have 3 jumpers and 4 shirts, I have 12 outfits. There's 12 ways that I can get to A to B through C. Well, there are 3 ways that I can get straight there. So I'm either going to go straight there, or I'm going to go on one of these roundabout ways. So how many options do I have? 15.
Are there?
How many ways can all these books be arranged in a row? Well, how many books do I have of each kind? I need to look at that and see. So I have 3 geometry, 4 trig, but they are the same. And I have 6 calculus. And I'm gonna put them in a row. All right? How many books do I have altogether? 13. How many ways can I arrange 13 things in a row? 13 factorial. Now, it so happens that some of the things I'm arranging are like M's. 2 or more M's in the word. So what do I need to divide by? 4 factorial. So whatever that is, when you type it in on your calculator, that will be the answer. The big number, 13 factorial divided by 4 factorial. That's the answer, not this. And type it in and get an answer. Now, what if I put them in a circle on a circle? So you got, in the library sometimes they have a circular shelf. What changes if I put them in a circle?
12.
Then it's 12 factorial, still divided by the duplicates. That hasn't changed. But when you arrange them in a circle, it's 1 less factorial. No beginning, no end to a circle.
That wouldn't change like the number of duplicates. Okay, wait, that came out wrong, but like, obviously it's not gonna change the number of books, but like, because there's 1 less way.
There's still 4 books that are the same, so all those have to be divided up. In a row with the books of each kind together. So what that means is all the geometries are in a cluster, the trigs are in a cluster, and the calculus are in a cluster. And I'm going down to my bookshelf, and I'm going to put these clusters on the bookshelf. How many things am I really arranging then? 3. So I start with 3 factorial. But when I tied a string around my geometry books, there were 3 of those. Those 3 themselves in their little cluster could have been rearranged 3 factorial ways. And the trig books, just hold your horses, could have been arranged 4 factorial ways, and the calculus book 6 factorial ways. But what? All the trigs are still identical, so I'm going to divide. These essentially cancel each other out, and if you want to do that ahead, that's absolutely fine. But I need you to understand that every bundle cluster is that factorial, and every duplicate is divided by factorial. If all of the trig books look exactly the same, they're exactly the same, then am I going to be able to see any difference in that? And that's why it all disappears in the problem. It all disappears.
Are there gonna be any of the, convergent, divergent problems on this review? Or
Well,
just
there's some limit questions somewhere, weren't there? I don't have any limit questions on this.
They're on the very back.
Oh, yeah, on the very back side there, so let's be organized though, let's go in order. Okay, so are we done with the back of page one? Nope, Josh? 14. A club has 45 members. And the membership committee has 3, how many different membership committees are possible? So basically, we have 45 people, and we have to pick 3. Is that 45C3 or 45P3? Those are your options. Why is it C? Order doesn't matter if they're a committee. Now, if we said, how many slates of officers are there? That would be like president, vice president, whatever. Then that would be a P. But when order doesn't matter, it's C, so it's just 45C3. All right, are we done on that page then? Nope, one more, Dom.
Can we do 15?
15, how many license plates begin with 2 letters, followed by 4 digits, or begin with 3 digits, followed by 3 letters. Assume that nothing repeats. Alright, so I can use everything, all my letters and all my numbers, but I can't repeat anything. Okay, let's do these first. Kids, please tell me you see a plus right here. So we're gonna multiply all that together. We're gonna multiply all that together, and then we're gonna multiply all that together, and then we're gonna add them together. Alright, I'll see what I have to do. Okay, so here we go. Need a letter. Pick a letter from the alphabet. How many choices?
26,
How many choices?
25.
25. Remember, we're not repeating. If they hadn't put that sentence in there, then it'd be 26 again. They said you can't repeat. How many digits? 10, 9, 8, 7. Now you're going to multiply all those together because you're picking letter and number and number and number and number, right? So we're going to get a number there. We're going to multiply all those together. Now, what's this one look like? Number, 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 and then letter, letter, letter. And those are all multiplied together. And then you'll take whatever answer you got here, and whatever answer you got there, and add them up. And that's the total number of license plates that would be possible. Okie dokie smokies? All right, going you back at 50. Back at 50, so for some more fun review.